Let's look at a summary of this section. The electric motor, the most common type of actuator, is based on the principle that a current carrying conductor will experience a physical force when in the presence of a magnetic field. The DC motor consists of a rotating armature and a stationary magnetic field. The current in the armature, which must come through the brushes, causes the rotating forces. The stationary magnetic field is provided by electromagnets, in which case is called a wound field motor, or by permanent magnets, in which case is called a permanent magnet motor. There are three types of wound field motors. The series motor has an armature and field winding connected in series. This type of motor is characterized by high starting torque and high no-load speed, but poor speed regulation. The speed changes considerably if the load changes. The shunt motor has the armature and field windings connected in parallel. This type of motor has much better speed regulation than does the series motor. The compound motor has series and shunt type field windings and combines the good characteristics of both the series and shunt motors. Permanent magnets, PM motors, use permanent magnets to provide the stationary magnetic field. This results in a very linear torque speed curve, which makes it easy to calculate the motor speed for various load conditions, and thus attractive for control system applications. There are two ways to control the speed of a DC motor. Analog drive uses linear amplifiers to provide a varying DC voltage to the motor. Although simple and direct, this method is very power inefficient and is usually used only with smaller motors. Pulse width modulation, PWM, a more efficient method, provides the motor with constant voltage pulses of varying widths. The wider the pulse, the more energy transferred to the motor. For larger DC motors, SCRs power the motor with pulses taken directly from the AC waveform. This is a form of PWM, and it eliminates the need for a large DC power supply. The newest type of DC motor is the brushless DC motor, or BLDC. This motor uses permanent magnets instead of coils in the armature, called the rotor, and so does not need brushes. The field coils are switched on and off in a rotating sequence that pulls the rotor round. BLDCs have built-in sensors that direct when the individual field coils are to be switched on and off. This ends our look at DC motors, although we will revisit them again when we look at the stepper motors.